I'm sure many of you have seen these glasses before, and you may even have a couple pairs lying around your house somewhere. Personally, I was never a huge fan of 3D movies, and I always left the theater with a bit of a headache. However, I became much more interested in these glasses when I learned that there is another animal who looks even more stylish wearing them than we do. You may be surprised to hear that this animal is the cuttlefish. The cuttlefish is a pretty cool animal, best known for their impressive ability to change the color and pattern of their skin using specialized color cells. Cuttlefish are cephalopods, a class which also includes other marine mollusks like squid and octopus. To summarize, we can confidently say that cuttlefish are quite a bit different from us humans. So how come they look so good wearing 3D glasses? Well, in their natural habitats, cuttlefish tend to prefer the no glasses look. However, in 2020, researchers at the University of Minnesota found that much like in humans, anaglyph glasses like these allow the cuttlefish to perceive two-dimensional images in 3 dimensions. So let's take a closer look. In a 3D film which makes use of this type of glasses, there will be 2 images presented on screen, which are slightly displaced from each other. Then the glasses work by filtering out specific wavelengths of light so that each eye is only receiving one of those 2 displaced images. This is perfect for us because our brains are very skilled at merging these 2 images and interpreting the difference between them. This is an ability called stereopsis. And after all, this is how we perceive depth all the time in our daily lives. So let's look at this using a simplified diagram. Imagine that we're watching a movie about cuttlefish. If we use these anaglyph glasses to filter out different wavelengths of light, our right eye will see only the red cuttlefish, while our left eye sees only the blue one. Because these images are the same, just slightly displaced, our brain is able to merge them into one single image, which we perceive in the location where these beams of light intersect. We can see how this would be the case if we instead imagine that we're looking at a real cuttlefish. Rays of light from a real cuttlefish that is located closer to us in space than the TV screen will reach our eyes in exactly the same way as the rays of light from those 2 displaced images. So when we look at these displaced images, our brain will infer that in fact the cuttlefish is jumping out of the screen towards us. If instead we wanted to perceive the cuttlefish as receding into the background, all we would need to do is swap the location of those 2 images. We can see that in this case, the rays of light correspond to a cuttlefish that is located further away from us. And so this is what our brain will perceive is happening. So for many of us, 3D films can be a fun way to spend an evening. But for researchers interested in visual systems, they can also provide some really helpful tools for studying how depth perception works in non-human animals. For example, the researchers at the University of Minnesota use some of these techniques in order to determine whether cuttlefish too can use stereopsis to perceive depth. In other words, whether they can use cues from displaced images in order to infer depth. So they began by training a cuttlefish to strike at a walking shrimp on a screen in order to receive a food reward. Then they equipped the animals with anaglyph glasses and observed what they would do when they were presented with 3D shrimp movies featuring differently displaced images. In the case where there's no displacement between the 2 images, we would expect the cuttlefish to perceive the shrimp as being located in the same plane as the screen. However, in this case, if the cuttlefish is able to make use of stereopsis, we would expect it to perceive the shrimp as being in front of the screen, and so it would need to back up a bit in order to accurately strike its prey. And in this case, we would expect the cuttlefish to perceive the shrimp as being located behind the screen, and so it would need to move closer. And this is exactly what the researchers observed. The cuttlefish did indeed change their position depending on the displacement of the images in the film, leading us to conclude that they can make use of stereopsis. So you may be thinking, yes, the cuttlefish looks great in its new glasses, but why should we care about this? Well, the fact that cuttlefish can make use of stereopsis in order to perceive depth is actually quite groundbreaking. After all, the evolutionary history of humans and cuttlefish diverged hundreds of millions of years ago. And up until very recently, it was thought that complex visual processes like stereopsis could only be found in higher order vertebrates like humans. This finding presents new and important understandings of what non-human animals, especially invertebrates, may be capable of, and it highlights just how much there's still to learn about the visual systems of other animals and the huge range of ways in which we can perceive the world. And if you have a cuttlefish in your life, maybe consider treating them to a 3D movie one of these days.